Morning guys, everyone is preparing well regarding NEET and mains because the countdown was started in days only and make it in hours, seconds and make a great success. So as far as our party is concerned, we should secure more than 120 marks. It's as it is we are doing the conceptual questionnaire only. So today the different expecting question from this part is going to be 4 marks from molecular orbital theory. Followed or not? According to these children, the molecular orbitals are going to be formed due to overlapping of same energetical, same oriented orbitals of the same kind of 2 atoms or different kind of atoms. That gives rise to 2 types of orbitals, high energetical, low energetical. The high energetical one is called Nana. It's going to be antibonding molecular orbitals. The low energetical one is called, what you say here, what's known as here bonding molecular orbitals. So this is the first case, and coming to learn the point. What's the point here? The atomic orbital should be same energetical as well as they belongs to same orientation along the axis or in between the axis. So that gives rise to that. Generally we will show addition. Addition means that's nothing but giving us constructive wave. Hence the overlap is maximum. The orbital is going to be in size increases. Subtraction means there is a what's called here. Here you are going to get here antibonding molecular orbital by the destructive wave formation. Constructive wave leads to bonding molecular orbital due to overlapping of positive lobe and positive lobe, and there is a destructive wave function due to overlapping of positive and negative lobes are concerned, children. So this is the another point which we have to discuss here. But when you have seen this, you are getting one nodal plane. And after this, children, we will do some questionnaire after this in the part 2 here. Basically, I am doing where there is greater than 14 electron system like oxygen, fluorine, and 14 electrons below 14 electrons is going to be shown here like this. What's called here 14 electrons and below 14 electrons. It's going to be 14 electrons below 14. So we have using a simplest way to remember these things here. What's called here? Generally, some people in Urdu or somebody else, they'll call it's called Abba. Abba means A. It's the one, sigma 2pz, and B means 2 orbitals. That's going to be what's called here pi 2px is equals to pi 2py. And again B is concerned pi star 2px and pi star 2py, and A again, that's called sigma star 2pz, children. A, B, B, A. Or else you can write it as 1, 2, 2, 1. So that's like what's known as here the order of energy is concerned. Like this it is going to be increases. It's a little reverse here. Coming to this, what is the energy increasing order in 14 electron system means? That's going to be 2 Baba. Baba B stands for second numerical value. 2, 1. 2, 1. That's pi 2px is equals to pi 2py, and sigma 2pz, pi star 2px is equals to pi star 2py, and sigma star 2pz, children. That's generally mentioned as Baba here. What's called here? What's that you are doing as far as 2 orbitals, 2, 1 orbital 1, 2, 1, 2, 1, 2, 1, 2, 1. So that's what we are using, a simplest way to remember, not required. Everybody knows this, but the energy related with the common energy 1s2, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. This is common for both. It's the common for both. This is the increasing order of energy related to 14 electrons, greater than 14 electron system, and it's 14 and less than 14 electron system, children. And this is the points which we are going to do. See here, this is what we have done, all the related questions, a decent question which you are going to get here. So this is going to have only one nodal plane. Once again I am recollecting you. And next one, the formulas which we are going to use: bond order Nb minus Na and bonding electrons minus anti-bonding electrons. Bond order is directly proportional to bonding molecular orbital electrons. Whenever bonding molecular orbital electrons increases, children, bond order also increases. When the anti-bonding molecular electrons increases, bond order decreases, Baba. That's why it's directly related with BMO, and BO is inversely related with ABMO electrons. Bond dissociation energy is directly proportional to bond order. As the number of bonds increases, bond strength increases, and dissociation energy also increases, children. And after that, it's going to be inversely related with our friend, that's nothing but bond length. So bond order increases, bond length is going to be decreases, because extent of overlap is going to be more. That's why, children, so BDE, bond dissociation energy, is directly proportional to bond order. Bond order is inversely related to bond length. Very decent formula which are very much useful for you, children. And after that, bond order with respect to total number of electrons. Very oldest technique. Everybody known, children, this one. What's called here? The order of whatever. The people will take 14 electron system as the reference. Then we go 13 to 0.5 bond order decreases. Like that, 0.5, 0.5, 0.5 bond order increases it. And when you come to exceptional cases, the friends are going to be 4, 8 and or going to be 20. That's going to be 0 bond order. Where there is a 0 bond order, they do not exist, children. So that's 8 electron system and also 4 electron system and also 20 electron system. I have given you, Baba, here. And one more, very, very interesting question that you have to learn, children. ABMO. If the anti-bonding molecular orbital electrons are going to be increases, what happens, children? Bond is going to be break down. The bonds are going to be break down. Very, very interesting, Baba, here that's going to be. When anti-bonding molecular orbital electron number decreases, the bonds are going to be formed. So that's the case where you have to learn. So that is going to be the question. Why? Because, so why the bond breaks means the energy of the system is going to be increases due to increase in number of anti-bonding electrons. Hence the bonds can be break down very easily. Whereas if they decreases, bonding molecular orbital electrons increases, no, children. That's why the bonds are going to be formed. Here is a very decent question, Nana, here. Here the bond order is 3, but here it is going to be 5. And here the bond order is 2, it's going to be 1.5. And as far as this, what is called here, 1.5, then when we are coming to this, 14, 16, 2, and whenever it comes to, that's going to be, it's going to be whatever is called here, 16 is going to be 2 and ABMO is going to be what you say 2.5. Follow, children? Just whatever is called here 2.5. 16, the bond order is related to what's called here, we have shown you 2, and coming to that 15 electron system is going to have what's called here, when you have seen this 2.5. And what I am doing is that instead of this, what I'll go for is this, means I'll go for O2 minus 1. That's going to be 1.5. Sorry for the interruption here. And coming to this CO2 CO plus 3. Very, very exceptional case, a very decent question here. And here it is 3, it's going to be 2.5. It's going to be what you say 2.5. And what is that means, children? My question is that in which case the bond order increases? CO2 CO plus the bond order increases. Why? That's the very, very decent concept here. It's based on the electronegativity difference CO2, CO plus, the bond order has been changed to 3.5. Why? Because children, the electron lost from high energetical sigma star to s orbital. This is the order is concerned. Whatever you are going to see here, this is the order of system. See, this is actual electronic order of the system. Hence, the bond order is going to be 3.5. 10 minus 3 by what's called here 2.5. That gives rise to this, children. So, and when we have seen this, no, this is the very exceptional case which you are going to increase the bond order. It's not decrease, children. Why? Because the electron is going to lose from antibonding sigma star to s orbital, children. This is the part 1 which we have done related to the MOT, Practice this, children. It's very decent question. Nowadays, this is going to be a trending question. Right from that, and last but not least, what I am doing, see here, I have given all the number of electrons, total number of electrons. When you are coming to that, after 14, 15th electron enters ABMO, 16th also enter ABMO, 17th, 18th, 19th, 20th electron also entering into antibonding orbitals, children. So this is what's called here MOT. Thank you, children. Thank you very much. Thank you one and all. Prepare well. Don't ignore them all.